Hello friends, this is the second of a series that we're doing on this Sony multi-channel AV receiver model STR-DH750. In the first part I tested it out and found out that it had some major problems, and in this episode we're going to do some more testing and also look inside it. Later in another episode we'll try to fix whatever is wrong with this and get it going again. Or if that doesn't work out, we may scrap it out for parts. So after my moments of discouragement yesterday, I've decided to pursue troubleshooting this and hopefully fixing it. Put in a sine wave at 1 kilohertz, which is on the bottom, and the voltage output on the top, which is highly amplified in scale, is just pure noise. So basically nothing's coming out. I've hooked up this speaker, can't hear anything. One of the interesting things is that the Bluetooth feature works, which is, for example, I'm using the Sony app. If I change the mode button, the display on the app changes along with it. And if I go to FM, I've got a monitor hooked up. I get a display to help me do the FM presets. I've also got a recent version Sony remote control that I got from another system that seems to operate this correctly. So basically we've got a lot of good things happening here, except the persistent problem of no display, and more importantly, no audio. I've switched to this speakers just in case that works in some way. We've got a sign that that this video coming out shows that there's some sort of microcontroller life in here. I don't know if the microcontroller is the same as the DSP chip or different. My guess is it's probably different, but we'll probably see when we look inside this. So I'm going to take a look at the inside of it here without knowing much about it, and I may have to pull a service manual somewhere if I don't get anywhere with just some basic troubleshooting. Pulled the screws out of it, 3 on each side, 3 on the back. Should be able to just slide off the top cover. I've also unplugged it for safety purposes. Let's see. This is kind of a lift and slide affair. Be right back. This is interesting. The last one I had, which was the Yamaha, had a slide back method, but this is a lift off method. See if I can do that with one hand. Okay. This gives us a chance to look at the inside. So the first step in any troubleshooting is always the visual inspection. That's where you get the most bang for your buck. A lot of times things can be quite simple and spotted visually in a matter of seconds, or if not, you can go on from there. Let's take a little tour of the inside while we're at it. We've got this, what I usually call power conditioner board. This looks like a small size power supply to keep maybe the Bluetooth circuitry and the remote control circuitry running. Power coming in here, fuse. I know the fuse is okay because the thing shows enough signs of life that the fuse isn't broken. This might be some sort of a varistor or something. Got probably a bridge rectifier here, some capacitors, and little probably switching power supply circuits here. We've got a board that runs the HDMI interface. The audio inputs from this side and outputs are captive through these connectors that go onto the main board. Got a couple of big capacitors here that are the main power supply probably. This is probably a big bridge rectifier for the main supply. We've got a big lineup of transistors. There's probably 2 for each channel. Let's count our transistors. 2, 4, 6, 8, 10, 12, 14. So 1 pair for each channel of 7 outputs, and then this has 2 subwoofer outputs, which wouldn't need a big driver transistor. Obviously we got this large vertical heatsink that's going to dissipate most of the heat. Some sort of a little board here. This might be just purely mechanical to kind of keep these cables from getting harmed by heat. Got the interface board here for the front panel switches, and there seems to be some sort of little board here. Oh, that's probably just stuck on there. It doesn't pertain to anything. Got our phono jack at the bottom, power supply switch here. So this board over here looks like kind of a main processing board. I'll take we'll see how close we can get in there with this camera. So we'll look at those separately and figure out what they are, but overall they look like elements of a microprocessor. As a guess, we've got, processor, memory chips, A to D and D to A converter chip, maybe on one big chip or multiple. Here in the center we've got lots of little pre-drivers, it looks like, for these power transistors. Along this line we've got resistors and capacitors and inductors that are probably have to do with the biasing of the transistors. So we've got these little transistors boosting the power into the bigger transistors. This can here connects to the FM, so that's probably our self-contained FM tuner with some sort of control cable here. Maybe the synthesizer for this is down on the board and comes up here through this cable. And maybe the FM detected audio goes out of there. So next I'm going to plug it back in and see if there's any obvious problems. I kind of don't think there will be that can be visually seen, but it's worth a try. Then we'll start checking some of our voltages and things to make sure those are good. So on the transformer, it looks like these are the AC inputs. These are probably the major power outputs for the audio driver circuitry. Got a small power output here to run this little continuous voltage supply probably, and another one to run some smaller power supply. This might be a power supply for the microprocessor section as kind of a guess. This one here also. Oh, looks like these lines go down here, so who knows if that's kind of some sort of sensing. Oh, and also for heat purposes, as is standard on these things, we've got vents on the bottom, feet on the bottom, and the ability for air to flow up and cool it convectively by going through these vertical fins. and ultimately through the top and side vents here. So another simple troubleshooting thing we can do is to reseat all the connectors. Got it unplugged. Before I do this, looks like everything is intact here. Not much to reseat actually, but it's worth trying. This cable is kind of interesting. It goes over here. It appears to be a power cable or audio cable that ultimately ends up here. Now that I think about it, that's probably just the USB cable connector. So it's hard to know what's on these boards. Here's something. Oh, this is probably the Bluetooth chip, I'm guessing, based on the location and the kind of the general look of it. So that probably delivers data down to here through this connector. This one I've noticed that we've looked at before says standby DC-DC PWB, meaning this is the PWB means printed wire board for the standby DC to DC converter supply. So that confirms what I pretty much knew from the topology. I don't see anything wrong here physically. The capacitors haven't burst. So the guess is that maybe the audio circuitry works, but there's some sort of major thing that shut down. The front panel does work to some extent. I was able to use that to set up the Bluetooth with a Bluetooth button, and also I could control the volume and the modes and see those switch on the app. So, you know, the best case would be that just the display doesn't work in some way. Like, let's say the display driver failed or the display itself failed, but everything else worked. But the fact that I can't get any audio to come out of it when controlling it with either the remote control or the app tells me that there's kind of a bigger problem than just a mere display. Problem I saw with another AV processor, which was a fairly old Bang & Olufsen unit that I covered in another video. Basically, they're so DSP centric that you don't have necessarily a really easy place to tap into to bypass the stuff that doesn't work. So let's say some part of the digital signal processing here doesn't work. One of these chips is probably an A to D converter, and maybe combined with a D to A converter, also known in the trade as a codec. And you know, there might be a few traces on these pins that drive ultimately each analog circuit here. It would take a lot of tracing down to, or maybe consulting the service manual and the schematic to find out where you could tap in to drive this amplifier with some external source. Like, let's say you wanted to convert this into a pure amplifier that doesn't have any of the AV signal processing functions. You'd have to figure out where to tap in the inputs for each channel. And there's some clues about that as far as going backwards from the power transistors to these smaller signal transistors. And we might be able to find a point where those ultimately go into some chip that can be identified as a D to A converter. And then we could look at the pinout of the chip to figure out where to tap in. Maybe you could lift the chip and then tap in at the pins of where the chip used to be that are the output pins. So that's a possibility, but honestly, amplifiers are so commonly available at thrift stores that you know, that's going to be more trouble than it's worth probably. So it's looking more and more like this thing is going to get scrapped out for parts. You know, if it worked perfectly, it would be worth reselling, certainly. But the level of money I've got in this at half of 35 was just $17.50. You know, it might make more sense to pull out the transformer and the heatsink and power supplies and all that kind of stuff. That's what I ended up doing with the Bang & Olufsen, which, you know, at some level is kind of a shame, but the honest truth is that these things are kind of designed and built to be thrown away when they're either obsolete or possibly go bad. I've still got the cover pulled off. I'm going to keep my fingers out of it to avoid a shock hazard. I'm going to turn it on and hope for a miracle that the display lights up, but you know, that's very much in the miracle category. In 3, 2, 1. Okay, no miracle. But we might be able to localize where some of these relay clicks come from. So it appears that these large black plastic pieces sticking up here are relays. The sound seems to kind of localize to there. That's the AB switch, which goes with the outputs are back behind there near those relays. So the relays would probably be very close to the output jacks themselves. I'm going to turn this on and off again. Seems to be the same relays, so my guess is that this is designed so when it's turned off the relays are disconnected. So maybe that's a protection feature for if you accidentally put a voltage on the outputs with it turned off, you don't harm anything. So that completes the second part of our 3-part series. In the third part, I'm going to take off this front panel unit and try to figure out if it can be fixed. If it can be fixed like Scooter is, that's wonderful, and if not, I'll scrap it out for parts or resell it for parts. So thanks for watching, and bye-bye.